Okay, can you let me know if YouTube is coming live? Oh, yes, I see it. There we go. There we go. Okay, that wasn't too hard to fix. Okay, well, we're now live on both Twitch and YouTube for Abnev Code 2024 Day 1, starting in 27 minutes. So I am warming up on Day 1 from previous years, starting with 2019. Okay, so what do we have here? A primer on collecting stars. Fuel required to launch a given module is based on its mass. Specifically, find the fuel required for a module, take its mass, divide by 3, round down, subtract 2. Easy enough. And what is my input? Total fuel requirement. To find it, individually calculate the fuel needed for the mass of each module. Okay, input, let's make this a list up to list. Puzzle inputs differ by user. Okay, I have some other things to fix. This is why we do this before the real problem hits. Okay. All right, so over on another screen, I'm gonna load up admin of code. So you don't see me taking my session key on camera. Okay, grabbed my key. No, it appears I already had the session key. All right. That is weird. Let me just try opening a new session. Okay. We're looking at what, 2019, day 1. Let's try other days just to make sure. Do we have anything? 2018 doesn't have much. Let's try that. Okay, I'm pretty sure I'm using the session key. They might have changed the way they do their requests. So I'm going to be off to the side here debugging a curl request. Actually, I think I can do that on screen. Okay, year, day. So we're doing something like this. Okay, in this case, what is source? Let's do 2019 and 1. And if we just did this URL, it's still the same URL, right? Yeah. So if I curl this, maybe the name of the session cookie has changed. Let me double check that. Nope. The session's name is just session. Okay, that might be something for me to debug tomorrow. And I'll just have to keep in mind that today I'm copy pasting. So this will be 2024 when it comes out. You've got 20 minutes. Okay. Okay. Here we go. Yes, we overwrite it. Wait, overwrite. No, that's the right thing. That's weird. Did it start working properly? I did not paste that in there. Okay. 2019, day 1. Let's just cat that again. Okay, I mean, well, now I've ruined it. Oh no, that must have been the day 9 input that I was just looking at. Okay, we'll fix that for day 2. Okay. Back to the problem. So we have our input, and these are all what masses? Needs to know the total fuel requirement, individually calculate the fuel needed for the mass of each module. Okay, so def required mass, and we'll just say it's an int. So we take mass, divide by 3, round it down. If we just use integer division, that does that automatically. And then minus 2. Okay. Maybe we could test that for like 12 and 14. 2, also 2. Okay, and then we get input map, well, to int required sum. Oh, yeah. Autocomplete knows what to do. 3154112. You gave an answer to recently. When did I try to give an answer? Whoa, is admin code buggy? Because I gave the right answer. Did I somehow make a double request? That'd be a fun night if AOC was buggy tonight. Okay, so here's part 2. Mass divided by 3, round down, subtract 2. Okay. That fuel also requires fuel. Okay, so we have to keep doing that repeatedly. Okay. So we could do like an infinite repeat. We need to generate an infinite sequence. Iterator dot, not quite continually, iterate. Okay, so if they give us an example 14, and we keep doing required, and I'm going to change the input to masses, val masses. And now there's just masses, map required, sum. So we have def full required. Okay, it sort of gets the right idea. We're just going to write it out here first. So let's say we start with 14, required. Let's just take 10, see what happens. 14, 2, we get negative 2. So the 2 required 2, that goes down to negative 2. So we have a little bit of a 2 divided by 3 rounded down to 0. Okay, so we'll just do a take while positive. And then what's another example they have? 1969, let's try that. 1969. Okay, 654, 216, 70, 21, 5, and then it goes negative. So we can basically do this, and we'll do a take while. Take while greater than 0. That's sum. And in their example here, we had, oh, right. We need the tail of that, and then the sum. Right, because the very first one's just going to be the 1969. Yeah, tail.sum. Or rather, drop 1. Okay, Uh, that's exactly the Copilot code. Okay, so this is what mass and then normal required. Great. So this is val ands 1 and then val ands 2 equals mass step map full required dot sum and 4728317. Hey, there we go. All right. Couple hiccups in our stream, but hey, you've got a warm up. Maybe I do 2018 day 1. And yeah, we can do that in 10 minutes. Oh, you know what? We might not do it in 10 minutes. I'm going to set a timer. 10-minute timer. Okay. And make sure it's unmuted. Okay, let's just go straight to the input. A bunch of positive and negative numbers. And we're going to save this as 2018. Oh, there's a big negative number at the bottom. Okay. Okay, so our input is just a bunch of integers. And what to do with that? Well, per the problem, you know what? I need to set this timer. Let's set it to 8 minutes because I'll need time to set up my 2024 day 1. Okay, same deal here. There's a briefing on the 50 stars. Device must be calibrated. A sequence of changes in frequency. So these are frequencies or changes in frequency. So they're like deltas. Then starting from 0, change at +1. So this is just a sum again. Okay. Input dot sum 585. But it's not really a sum, is it? Okay. To calibrate the device, you need to find the first frequency it reaches twice. The first frequency it reaches twice. So as I get these frequencies, I could just add it to a hash set. And once that hash set contains, so we're just going to do a scan left. starting with 0 and add. Okay, so this would be the values as you add the deltas. And the last one, just to sanity check, should be 585. Okay, cool. And well, F's. We need the first F that's hit twice. So we're just going to do a fold. F stop fold left. And then we have an empty set of int. Let's see. F's is already a list. Should I be doing it this way? I shouldn't be doing it this way. There's a built-in somewhere. Well, it'll be efficient enough. We're just going to do it. So, scene, and if that F isn't seen, then we return it. In fact, we just need that set. So we have, oh, I don't like this autocomplete. Okay. Scene, and we have a new frequency. And if scene F, then we return early. Fold left doesn't really terminate early. I should be doing like, okay, I should be doing an unfold with the list of remaining frequencies to check. But we can just make this a function. F. See, you know what? We're just gonna do an unfold. Oh my, I am rusty. And then F's. Well, yeah, just F's. Is this the right idea? If scene F, then return none. We end termination. Or, you know what? We can also do F's dot. You know what? What's the size of F's? We should just make this fast. F's dot size 1000. We can do n squared here. Okay. F's dot find. Okay. And we'll clean this up later because we have like 30 seconds. F's take I contains F. Yeah. It found none. So maybe I misunderstood something. The first frequency reached twice is 2 in what example? Um, +1 minus 2 plus 3. 1 minus 2, 3, 1. The device continues from the start of the list. The list of changes they're talking about is this one, right? No. 1, -2, -3, 1. Oh, it keeps repeating. Okay, so there is none in here. So it's going to be more than 1,000 squared. Okay, well, we'll do this another time. Let's make sure we're set up. For 2024. All right. Day 1 starting in a minute. And we are ready to get our input. Day 01.text. Now let's take 2018. We'll resave that as 2024. All right. Here we go. Okay, looking straight at the input. We have a bunch of pairs of 2 numbers. Okay. I imagine we parse that into just 2 numbers. Story. Locations are listed not by name, by a number called location ID. The historians split into 2 groups, each searching the office trying to create their own complete list of location IDs. By holding the 2 lists up side by side, it quickly becomes clear that the lists aren't very similar. Maybe you can help them. Okay, so there are 2 lists of location IDs. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left with the smallest in the right. So we just sort both lists. And then within each pair, figure out how far apart they are. And then add up all of those distances. Okay. Input, not map. Okay, so we have, well, pairs. Okay, I don't like this autocomplete. So we're gonna take line dot, yeah, fine, we split on that. And each of them map to int. We don't need combinations. I don't know why it does that. And what's this going to be? An array? Val LR. You know what? This is actually fine. So we're going to take both of these lists, and then we're just going to, we can make this a list. So we now have a nested list. And then we're going to transpose it. Okay, so val, we'll just call them the groups dot transpose val group one. We can't transpose. Okay, right, split. There's some double spaces in there. Not filter, not empty. Or hold on, we have some empty strings here, right? Because of the split. Can't we do this as a regex? So we're gonna do like space star or space plus. Okay, great. So we have the two lists. Group one, that's sorted. And we can zip that with group two, that's sorted. And for each of those, you want the difference. That map case L and R. So we're going to do L minus R and take the absolute value of that, dot abs. And then that's sum, and that's ans1. Okay. 1110981. Part 2. Okay, the two lists are very different. What exactly were the historians doing? The list of locations to check is empty. Okay, well, what do we do with these? Which group made mistakes or how to read the handwriting? You notice a detail. A lot of locations appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. How often each number from the left list appears in the right? Calculate the total similarity score by adding up each number in the left list after multiplying it by the number of times it appears in the right. Okay. Well, we're just going to take group 2 and make it a set of counts. We're just going to do a group map, reduce to get the counts. We'll just call it counts. So identity, exactly that. And then group 1, each number from the left list. So what if something appears on the left list twice? So left list is 3. Okay, so even if it repeats, we do it multiple times. So group 1 map counts. Well, not quite just counts. Map and so counts n times n. Yeah. And then we take the sum of that, right? Similarity score after multiplying it by the number of times it appears. Okay. And if it does not appear at all, say 1. So we want a default value of 0. With default value of 0. Okay, there's our answer. So we have 248,69388. There we go. Okay, that wasn't bad. Maybe I'll do a little bit of cleanup. 7 minutes. I feel like that's slow on a global scale, but I want to see how did the pros do. I mean, surely like they were done in 1 minute, 2 minutes. Thank you, thank you. Yeah, I wasn't even top 1,000. I kind of slowed down for part 2, didn't I? I mean, all I had to do was get the counts and then do this. I just have slow reading comprehension. All right, let's clean this up a little bit. We'll call this like left and right. Um, okay, split on the space and transpose. Left sorted, right sorted. Um, hmm. We could have just done map. I mean, I don't think that's necessarily more legible, but here, right? This is just my counting idiom with default value 0. Okay, that's what we'll stick with. Solve AOC 2024, day 1. Okay, this might be a good time to go back to that 2018 problem. Make sure I can't leave that unresolved. Okay, so this repeats, and we have to keep that in mind. Let's see. We're going to do this with the example. So I want to take this example list and have it repeat itself. So we're going to do x dot. Can I do to lazy list? No. Lazy list dot from specific. And then onto frequencies. Okay, so a recursive definition here. And let's try that. Frequencies dot take 10. Oh, this needs a type. Lazy list of int. Okay, so we have our repeating frequencies. And looking at the example, So what problem was this? This was 2018, day 1. You need to find the first frequency that it reaches twice. Yeah, so I basically take our frequencies, fold it into a list. We have some sort of early termination, which tells me I can use I was overthinking it, trying to use some other function. I think this is a case where I just want a recursive function. And maybe if we see a pattern, we can use a library method. Hmm. Okay. So, oh, we've missed something here. This isn't the frequencies. Oh, hold on. So these are the deltas. And frequencies is defined in terms of deltas. So, well, yes, exactly that. Okay, so now if we were to take frequencies, so we're going to have a list of values, but these values won't necessarily be repeating. All right. So in our example, +1 minus 2 plus 3 plus 1 resulting in 3. And then 4 plus 1 to 4 minus 2 resulting in 2. I'm not getting the same thing. So we have 1, -1, 2, 3, and then 3, 4, 3. All right, I think I know what's going on here. Let's take a look at our deltas. Oh, right. This is why. This is not a recursive definition anymore. Here we go. 1, -2, 3, 1. 1, -2, 3, 1. Okay, 1, -1, 2, 3, 4, 5, 2, 4, 2. Okay. So the answer we're looking for here is 2. And now we can define our first repeat. Um, a scan left. Interesting. Yeah, the scene frequency return to this isn't what I'm looking. I don't want to write code like that. Yeah, I don't want to return in there. So we're gonna have a search function, scene set int, and then to check is going to be a lazy list of int, and then to check. Yeah, we imagine this head and a tail. Okay, so nope, that's not what I want. So if head is seen, we return it. If seen h, then h, else we search recursively. So scene plus H and then tail. And otherwise, what is this otherwise? We're never not going to have a list to check because that's infinite. Okay, and then we just starting from an empty set and the frequencies, val and 2. And in this case, it's 2 for the example, but we don't want the example, we want the input. Oh, this was ands 1. Specific input. Okay, what happens here? We get a stack overflow error. Okay, we need to define. Okay, we need to make this tail recursive. And it's a limitation of worksheets that tail recursion needs to be defined, or tail recursive functions need to be defined inside of an object. So we're going to do foo.search. There we go, 83173. 83173. Okay. Okay, so there are other ways to check for duplicates or search cycles in a list. And I should have this as a library method. I've done this a few times when I've needed to have performance in, say, Project Euler. There's a trick where you have basically two pointers in the list, and one's moving faster than the other. And that's less memory intensive. I mean, in this case, though, this is plain performant. So if we do frequencies, find 8317, or like index of 83173. And if you search from there, let's just drop 974. Okay, so we had to go 142,000 times. So we built a hash set that's like nearly 15,000. I mean, so that's not ideal if we had big numbers here. But we didn't, so this works. Alrighty. Well, that's enough for tonight. I think that's a good warm up. I think we'll be ready for a smoother stream tomorrow night. Let's check private leaderboards. Who else was on mine tonight? Okay, I tied for third with Rascal 2. Gupta, of course, always snappy. Oh, I don't have all of my extensions running because I want to see like deltas for today's problem. Maybe I have an extension that's out of date. Oh, Alka, hey. Hey, how are you? So, Welcome. Um, I'm already finished for today. I was just gonna look at leaderboards and whatnot. I also did a couple extra problems. I'll put this up here um, because this one was kind of fun. This was day one from 2018. So I did this as a warm up of sorts. And what we had here. How'd your stream go, by the way, Alka? It's good to see you. It's good to be back doing admin code. Oh, I don't know what these errors are. Oh, there we go. Yeah, yeah. It was a quick one today. It took me 4 minutes. I feel like with the first view it's like reading comprehension. It takes me a while to read the problem. Um, Let me see my code for this year. Okay, I mean this was just one-liners. So parsing this, you split on the space and then you transpose that you have two lists instead of one for each line. Then you zip to get the difference, get the absolute value, sum it up, and then you get the counts. It's all very straightforward. Just write what the problem says. But day one from 2018 was actually a little bit more interesting. So here we have a list of deltas. Let me see the input. Yeah, so these are deltas. So the frequency is changing. And the first part was just to know what the final frequency was. But for part two, we want to see the first frequency that repeated itself. Um, and it turns out, so even though this input, how many is there? There's only 1,000 in the input. Those deltas keep repeating, so you have to cycle those. So here I made an infinite cycle of those deltas. So I could then make an infinite list of frequencies, and then within that you have to find the first one that repeats itself. And I just did this with a hash set. It ended up putting, oh, not just 15,000, 150,000 in that hash set. Yeah, so you have to search through 150,000 to find the first repeat. So it's interesting that for day one, you already had a problem where you couldn't just do like the n squared brute force whatnot. You do have to optimize somewhat. I mean, in this case, like a hash set works, but you are dumping 150K into there. I didn't realize that. Um, and right now, I'm just trying to look at the leaderboards. It seems like the plugin. Let me just debug that real quick. Okay, so admin of code charts. Ah, here we go. Here we have charts now. Okay, so these are the kind of stats I'm looking for. On my personal leaderboard, today I was fourth place for part one. And I guess I was also fourth place for part two, but people. Oh, ranks really changed for part two. Wow. Look at that variation. I mean, Alexander was first for both parts. Midnight Sam was second and then third. And then Gupta was third and then second. Oh, no. Midnight Sam was second and then ninth for part two. I see. Yeah. I'm on so many leaderboards. You're always high up on my leaderboard. I'm on some leaderboards where I'm sure I'm way past 15th. Okay, but that leaves me tied for third. Rascal 2 did fifth place for part one, and then third for. Okay, that explains why we're the same rank. See, I'm the only one that's consistent. I'm consistently off of the leader of the podium. Okay, this will be fun to follow. But for now, I am done. Let's see if anyone else is still working on admin code. Surely, I don't know, maybe someone started late. Bad Cop. I think I remember Bad Cop. You know, they're still working on 2024 day one. So yeah, let's have a peek. All right, Alka, Gupta, good to see you both. Thanks for stopping by. And oops. Okay, and we'll give Bad Cop a raid. Say hi, don't spoil things, and have a good one. We'll see y'all tomorrow.